Within days of the July 1st, 2025 announcement about Comet 3I Atlas, social media erupted with claims of leaked telescope imagery from a supposed NASA technician. While the agency and observatories denied any such release, the rumor tore through online communities, sparking fierce debate and casting doubt on the transparency of planetary defense operations. The question soon became, what triggered this rumor, and why did NASA's silence only heighten mistrust? Hours after the official Atlas news dropped, the story began spreading rapidly. It started with scattered posts on X and Reddit, each one amplifying the mystery. The earliest post, found on a fringe science forum, appeared at 9:18 p.m. Universal Time Coordinated. Around the same time, astronomers were first sharing verified Atlas sightings. The claim was sensational but vague. An unnamed observatory technician had leaked raw, unedited images of Comet 3I Atlas, and NASA was allegedly refusing to confirm or deny them. No proof, no link, just a screenshot of text that ricocheted across Telegram and Discord. By midnight, the hashtag #AtlasLeakTag was trending in several nations. On TikTok, a clip showing blurry, unidentified photos gained 40,000 views in under an hour. Threads on r/astronomy and r/UFOs quickly filled with both believers and skeptics, arguing over authenticity. Yet there were no files, no verifiable origin, and no traceable metadata. Ironically, skepticism only fueled the story's momentum. A popular YouTube creator joined in with a video titled "NASA Caught Hiding Interstellar Comet Images," overlaying dramatic music on filtered Gemini and Hubble visuals. Viewers flooded comments debating whether these were actual raw captures or reprocessed press images. The video surged to 50,000 views by morning. On Facebook, multiple space-themed pages repeated variations of the same claim, each adding more sensational details, some alleging artificial structures in the imagery, others claiming the whistleblower had vanished. None provided evidence. By July 2nd, the rumor went global, spreading in Spanish, Russian, and Japanese posts. Moderators began tagging viral versions as unverified, but fact-checking barely slowed the wildfire. The lack of an explicit denial became symbolic proof for some, while prompting deeper skepticism in others. In under a day, a single anonymous post had spiraled into an international controversy that polarized the scientific community. By dawn on July 2nd, two clear factions had formed, believers citing the silence as a NASA cover-up, and analysts dissecting every pixel in search of truth. The hashtag #AtlasLeak reached 120,000 mentions by noon, with X and TikTok driving the largest engagement. Comment threads ranged from informed astrophysics discussions to wild conspiracy theories. Some users swore the images showed alien construction, others countered by exposing color filters or reused public photos. Prominent science communicator Phil Plait, the bad astronomer, intervened on X, stating that if any leak existed, the original FITS files should surface, otherwise it was baseless noise. His post earned 4,000 likes within 2 hours, but was soon overtaken by chaotic reply chains, spawning new myths. Moderators on r/astronomy locked the thread after over 1,200 comments, citing waves of unverifiable claims. Independent users began charting the rumor's virality, identifying automated accounts and meme aggregators that boosted it into trending status across Brazil and Japan. TikTok creators stitched reaction videos, including one dramatic reading of the first forum post that drew 80,000 views before lunch. NASA's continued silence took on meaning of its own. For every plea urging patience for peer-reviewed confirmation, another insisted the quiet was deliberate concealment. News outlets joined the frenzy, with morning programs airing segments about the comet debate. Press inquiries to NASA yielded only one statement: verified data would be released after proper analysis. Within the confusion, fakes, speculation, and unverifiable insider reports tangled together. Some posts referenced supposed whistleblowers who never appeared. By day's end, everyone agreed on one fact: no raw data had surfaced. But the cultural battle of transparency versus secrecy had become bigger than the comet itself. On July 1, 2025, as the Atlas Observatory in Chile scanned the night sky, its system detected a fast-moving anomaly, an object racing toward the sun at over 130,000 miles per hour. This was no ordinary comet. The Minor Planet Center received the alert within minutes, prompting astronomers across the globe to simulate its orbit and verify its origins. The data confirmed it. The trajectory was hyperbolic and unbound, marking it as an interstellar traveler. By day's end, the center published an official notice confirming the Atlas team's findings. Humanity had just discovered its third known visitor from another star after 2017's Oumuamua and 2019's Borisov. Now 3I Atlas joins the historic list, designated as the third confirmed interstellar object ever observed. Early size estimates based on initial photometric readings indicate a nucleus nearly 15 miles across, substantially larger than either of its predecessors. Its velocity sets a new benchmark as well, calculated at over 210,000 kilometers per hour, faster than any comet or asteroid previously tracked, escaping the sun's gravitational influence. Astronomers rushed to calculate its trajectory with precision. Perihelion, the comet's closest approach to the sun, is projected for late October, leaving only a narrow window for Earth and space telescopes to study it before it fades beyond observation. The Atlas survey system, originally built for planetary defense, suddenly takes the lead in interstellar research efforts. Automated algorithms assess the image data for astrometric accuracy. Each successive observation tightens orbital models, reducing uncertainty. When the Minor Planet Center publishes its official bulletin, it sparks a surge of follow-up attempts from observatories across the globe. The urgency is palpable. With every hour that passes, the opportunity to collect data diminishes. This is no ordinary discovery. Its sheer rarity drives scientists into action. Teams at Gemini, the Very Large Telescope, and Hubble schedule urgent observation sessions. The comet's brightness, incredible speed, and potential age, likely predating our solar system by billions of years, add unparalleled significance. For researchers, this is a glimpse into untouched material from another star system. For the Atlas survey team, it serves as vindication for years of persistence and refining a tool built to catch exactly this kind of fleeting visitor. By the evening of July 2nd, the fundamentals are clear. 3I Atlas is enormous, fast, and foreign. Its classification as an interstellar object becomes official, and the countdown begins to record every possible detail before it disappears forever. On July 15, 2025, atop Mauna Kea, the Gemini North Telescope captures a sequence destined to become iconic. Over one night, astronomers gather 16 exposures, each through a different optical filter. The result is a mesmerizing time-lapse of 3I Atlas gliding through a sea of stars, its glow flickering in blue, green, and red hues. These colors, derived from meticulous stacking and filter techniques, not manipulation, highlight the spectral composition of gases and dust streaming from the comet's core. As soon as the raw images are transferred from observatory servers, processing begins. Calibration files are applied to remove noise, cosmic ray interference, and sensor artifacts. Each frame is aligned within a fraction of a pixel before being merged into a seamless composite that maximizes clarity and minimizes distortion. The end result is both evidence and artistry, an observation of an object that, mere days earlier, humanity hadn't known existed. By late July, Gemini South in Chile joins the campaign. On August 27th, a new batch of images captures what astronomers had anticipated, a faint but distinct tail unfurling from the nucleus. Solar heating has begun sublimating surface ices, sending out plumes of gas and particles. Veteran comet scientist Karen Meach of the University of Hawaii describes the moment as both a profound scientific achievement and a source of wonder, remarking that as 3I Atlas retreats into interstellar darkness once more, the observations stand as a testament to human curiosity. Additional observatories contribute their own datasets. In the Atacama Desert, the Very Large Telescope captures sharp composites using adaptive optics to counter atmospheric distortion. Hubble's late July imagery reveals the intricate structure of the coma and tail under extreme magnification. Each observation arrives complete with a metadata chain, timestamps, instrument configurations, calibration records, turning each photo from visual beauty into a precise measurement. Together, they form the evolving scientific portrait of 3I Atlas. The variety of verified data sources is remarkable. Atlas, Gemini, the Very Large Telescope, Hubble, and soon Webb each contribute a unique perspective and method. Some employ wideband filters to capture faint structural details, while others analyze dispersed spectra to identify molecular traces of water, carbon dioxide, or rare ices. Every dataset follows strict processing guidelines, with both raw and refined data stored for eventual public access once review is complete. To scientists, these images represent more than evidence of detection. They are a view into the history of another solar system and a demonstration of how rapidly global research networks can coordinate. Within only a few weeks, the narrative has shifted from rumors and speculation to a verified collection of peer-reviewed observations, each a milestone in studying a visitor that will soon be gone. All data collected by NASA-funded telescopes follow regulated paths. Photofated paths. From capture to publication, detailed under SPD 41A, NASA's policy for scientific information management. Ordinarily, missions retain raw data for 6 to 12 months to allow principal investigators time for analysis. However, high-impact events like interstellar object detections sometimes accelerate that schedule. Even so, nothing is released publicly without an electronic record of access. Digital archive curators at MAST and Gemini track every file, documenting user IDs, timestamps, and download sources. If someone retrieves raw data prematurely, the system logs it automatically. Each observatory manages its internal hierarchies, pipeline engineers, archivists, and investigators, all assigned distinct access permissions. Any irregular access triggers internal reviews or formal audits. Uploading material outside sanctioned channels would require defeating not only security credentials, but also the digital audits that record every transfer. This is why the concept of an anonymous technician leaking unprocessed 3I Atlas images conflicts with the reality of secure data management. NASA's apparent silence after the claims reflects systematic due diligence, not avoidance. Public comment comes only after verifying logs, completing audits, and confirming data custody. Tracing the supposed origin of leaked 3I Atlas imagery demands a forensic approach, platform to platform, post to post. Analysts comb through sites like X, Reddit, Telegram, and Discord, using reverse search tools such as Tinny and Google Images to locate genuine uploads or hidden metadata. Every trace leads back to official sources, Atlas, Gemini, Hubble, or VLT. No evidence of technician-derived data emerges. The alleged leaks are merely altered or recolored editions of legitimate public releases. Archive stewards at MAST and Gemini review their access histories, confirming all downloads are properly accounted for under registered IDs. No anomalies surface and no data is missing. When the University of Hawaii and NASA respond to Freedom of Information Act inquiries, their statements align completely. All data connected to 3I Atlas followed official release protocols with no unauthorized transmissions or whistleblower incidents. Reverse image searches continue to return only reposted press material. Every so-called exclusive found on social networks or video platforms traces back to publicly available archives. Nowhere is there a credible digital trail supporting the existence of a leak. After extensive verification, investigators determined that no technician, no breach, and no off-record imagery exist outside authorized databases. By this stage, global fascination with 3I Atlas has surpassed the tempo of validated science, but the real consequences occur quietly inside data centers and research institutes. When speculation overruns empirical review, the divide between rumor and evidence becomes more than an online distraction. For planetary defense specialists, delays as small as a single day in confirming imagery can hinder trajectory modeling and composition studies. Accuracy is critical when monitoring an object moving over 130,000 miles per hour. Those seeking clarity can invoke the Freedom of Information Act to request internal documentation, email correspondence, chain of custody logs, or validation notes associated with the comet's data. A ready-made FOIA request form circulates in astronomy forums addressed to NASA's Disclosure Office, requesting processing histories and custody records. Urgent findings have in the past received accelerated data releases when public interest or scientific merit warranted it, yet the procedural timeline still rarely matches the pace of social media. Some experts argue that improved transparency, faster data access, open audit trails, and visible custodial oversight is the surest way to restore confidence. Others caution that haste can foster errors and misreadings, particularly with uncalibrated data requiring expert correction. Ultimately, the task of reconciling public perception with factual process rests with NASA's Communications Division, whose next statement may determine how this episode is remembered. The lingering question endures. In an age dominated by instant commentary, where does the balance lie among speed, precision, and trust? On July 1, 2025, the Atlas survey identified 3I Atlas, marking humanity's third documented interstellar object. Major observatories such as Gemini soon released verified imagery aligned with established custody standards. Despite viral posts alleging insider leaks, exhaustive forensic analysis uncovered no unauthorized transfers or technician-linked materials. NASA's Open Data Framework under SPD 41A, mandating a temporary proprietary phase, clarifies the absence of immediate raw content. What remains uncertain is the origin of those misleading online visuals and the motives of their anonymous sources. As of now, all confirmed 3I Atlas data originates solely from Theragen sanctioned research channels. This entire episode underscores the growing challenge of distinguishing viral misinformation from genuine discovery in the digital era. For those seeking truth, official data repositories and formal FOIA procedures remain the only dependable routes to verified information.